Bismillahirrahmanirrahim. Still, we are discussing the logarithmic function. We spoke about the logarithm of some expressions or converted the exponential function to logarithmic form and the reverse, and we evaluated some expressions written in logarithmic form in the last part. In this part, we are going to speak about the logarithmic function. The function, or written in this form, f of x equal to log b of x, where x is greater than 0, b is positive number, is called the logarithmic function. As we mentioned before, the logarithmic function is the inverse of the exponential function. So we have logarithmic function and we have exponential functions. These are inverses of each other. And the condition given here, x greater than 0, this will give me the domain of the logarithmic function. The quantity with the logarithm must be positive. So the domain for the exponential function for this one is equal to 0 to infinity. So the domain for the logarithmic function from 0 to infinity for this basic one. This quantity with the logarithm is equal, it must be a positive quantity. It can be polynomial or square root or whatever, but this quantity must be positive. If I have polynomial, I have to solve it to see where it is positive and where it is negative, and we have to choose the positive part, or in which this function will be positive. That will be the domain of the logarithmic function. So in this part, we are going to focus on the domain of the logarithmic function. Find the domain of the function. Number one. For that, we have this logarithmic function, which is f of x equal to log base 2 of x minus 3. And I need to find the domain for this function. Based on the given condition in the definition of the logarithmic function, this part must be positive. So to find the domain, we have to say that x minus 3 must be positive, must be greater than 0. This means x will be greater than 3. This is the domain. Or I can write it in the interval notation. The domain is equal to 3 to infinity. So the domain for this one is 3 to infinity. Let's take another one. Number 2. F of x equal to logarithm of 3, let's say this time 2 minus x. Again, the domain for this one, we say that 2 minus x must be greater than 0. I have this linear inequality. So 2 minus x is greater than 0. This will give me 2 is greater than x, or x is less than 2. So the domain for this one will be x is less than 2. Go to the left. So it is from minus infinity to 2 open. So this is open interval from minus infinity to 2. Let's take another one. Number 3. f of x equal to log base 4 of x divided by x minus 1. And I need to find the domain for this function. Logarithm of x divided by x minus 1 with the base 4. So to find the domain, again, we will say that x over x minus 1 is greater than 0. So I have a rational polynomial here. X divided by x minus 1 is greater than 0. And to find the interval in which this inequality is positive, we have to find the critical point first. So critical values or critical point for this inequality. We will take the numerator x equal to 0 and x minus 1 equal to 0. This will give me x equal to 1. This we will call it the critical point. Now, the second step, I need to test the sign of the inequality around this point. This is step number 1. Step number 2, check the sign. Of the inequality. I have 0 and 1. Now less than 0, I can choose the number minus 1. Between 0 and 1/2, I will take 1 over 2. Greater than 1, I will choose the number 2. Now substitute minus 1 in the inequality. Replace x by minus 1 up and down. So if it is minus 1, it will be minus 1 divided by minus 1 minus 1. That will be minus 1 divided by minus 2 equal to 1/2. So the sign is positive. If we replace x by minus 1, I will get positive sign. Now if I replace x by half, that will be the second interval. Replace x by 1/2. It is 1/2 divided by 1/2 minus 1. That will give me 1/2 divided by minus 1/2 equal to minus 1. The sign is negative. It means in the interval between 0 and 1, I have negative sign. In the third part, I choose number 2. That is greater than 1. I choose number 2. If we replace x by 2, I have 2 divided by 2 minus 1 is equal to 2. This is positive. So in this interval, I have positive sign. The sign of the inequality will be positive in the first interval, negative between 0 and 1, positive in the interval greater than 1. And since we are looking for greater than 0, so my solution will be this interval. Take the positive sign. So I will say the domain in this case is equal to D, the domain is equal to this interval. It is less than 0. It means from minus infinity to 0. It is this interval. And this one. Union to infinity. And the interval must be open because x cannot be equal to 0 and it cannot be, I'm sorry, this is 1, not 2. This is 1, taking this value. So from minus infinity to 0, union 1 to infinity. This is the domain of this given function. Take one more example. Number 4. Let's find the domain of the function f of x equal to log base, let's say 2 of x squared 7x plus 10. and I need to find the domain. Again, to find the domain, we have to say that x squared, this one, plus 7x plus 10 must be greater than 0. So I have quadratic inequality or non-linear inequality. As we did before, we have to find the critical point or critical values. So to find the critical values, I will say x squared plus 7x plus 10 equal to 0. This is a quadratic equation. We have to solve it to find the value of x, either by factoring or completing the square or by the quadratic formula. This is a quadratic equation and can be solved by any technique of the mentioned three, by completing the square or by factoring or by the quadratic formula. If I do it by factoring, I will have x plus 2 and x plus 5 equal to 0. It means x equal to minus 2 or x equal to minus 5. So these are the critical values. I'll call them critical values. I have minus 5 and minus 2. Now, choose values less than minus 5, between minus 5 and minus 2, and greater than minus 2. Less than minus 5, we can choose minus 6. Between minus 5 and minus 2, I can take minus 3. Greater than minus 2, I can choose 0. Now, if we replace x by minus 6 in the given inequality, it is in this one. Replace x by minus 6. I will have minus 6 square is equal to 36 minus 42 plus 10, which is equal to plus 4. So the sign is positive. We are looking for the sign of the value. It is plus 4. Between minus 5 and minus 2, it is minus 3. Replace x by minus 3 this time. I will get 9. Minus 3 square is 9. Minus 7 times 3 is 21 plus 10, which is equal to minus 2. The sign is negative. Greater than minus 2, we choose 0. Again, what is there in the inequality? I will have 0 plus 10, which is equal to plus 10. So it is positive. And we are looking for positive sign because this is greater than 0. So the domain will be the positive sign. In this case, the domain for this function is equal to, it is this interval and this interval. From minus infinity to minus 5 open, union minus 2 to infinity. So this is the domain of the given function. So again, to find the domain for the logarithmic function, we have to take the quantity with the logarithm and make inequality greater than 0. If it is linear, it will be easy to solve. If it is non-linear, either fractional or quadratic, we have to find the critical values. Then we have to test the sign of the inequality in the different intervals. And then choose the positive one or the one that will give me greater than 0.